Experiment 6, Chemical Reactions. We are going to start by looking at some single replacement reactions. So you can see copies of pages from your lab manual on the screen. Off to the left, we have the single replacement reactions where you need to predict the products and balance the equations. There's a separate video showing how to do this. What we're going to focus on in this video is this bottom portion here. So this is where we're going to record our observations for the following experiments. So we have a little close-up off to the right. So the first experiment we're going to look at is we're going to take silver 1 nitrate, so this AgNO3, and we're going to react it with solid copper. In this box here is where we're going to write our observations. So if nothing happened, no color change, no bubbles, nothing like that, we would write NR for no reaction. However, if we do see something happen, we would simply either put an X there indicating a reaction occurred or writing what we saw. So we're going to follow this across. The first experiment that we will see on the next slide will have silver 1 nitrate with solid copper. Then we'll see silver 1 nitrate with solid zinc. And last but not least, silver 1 nitrate with solid lead. So the first reaction, we have silver 1 nitrate, and this AQ is indicating it's aqueous, which means it is dissolved in water. So you'll notice in the test tube here, this is where the silver 1 nitrate is. It is a clear, colorless solution. Then we're going to add solid copper to it. And you can see these small copper wires on the white plate. So those were added into the test tube with the silver 1 nitrate. And notice on the product side, off to the right, what we see. So record any observations. Did a reaction happen? Well, I definitely see a color change. And then notice the solid at the bottom, it's no longer coppery colored. So what we would do is go back to where silver 1 nitrate and copper is, and we would write what we see. So we saw a color change from colorless to light blue. You saw the copper, no longer coppery colored, but more of a blackish solid. So record those observations here. Next, we're going to look at silver 1 nitrate once again, but this time we're going to add solid zinc to it. So we have the clear colorless solution of silver 1 nitrate. You can see the little zinc pellets right here. They are shiny silver. We add those solid zinc into the silver 1 nitrate test tube, and this is the result here. So notice there is changes, so a reaction definitely happened. Make sure that you are recording those observations in this empty space here, indicating that the silver 1 nitrate and zinc reacted. Next, we have silver 1 nitrate. It's a little bit blurry, and we're reacting it with solid lead now. So we have the clear colorless silver 1 nitrate solution, and we have these lead chunks here. So the lead was added to the silver 1 nitrate, and you can see definite bubbles, some foaming going on, so a reaction is occurring. So you'll go ahead and record your observations for that reaction here. Silver 1 nitrate with solid lead. So next we're looking at copper 2 nitrate reacting with solid copper. So for this one, notice that the metal is the same in both cases. So we have Cu, Cu. So in single replacement reactions, what we have is we have the metal by itself replacing the metal that's in the compound. In this case, it's the same metal in both cases. So when that occurs, you'll see that the reactants on this side of the equation are exactly the same as the products on this side. So if the reactants and products are the same, that means no actual reaction is happening. Nothing has changed. So if nothing has changed, means that there is no reaction. So for this one, you would write NR in the space for your observations. So let's look at how that looks. We just looked at copper 2 nitrate reacting with solid copper. So it'll be this box here. So since it's the same metal switching places, no actual reactions happening, so we would just write NR. And if you want to follow it over, that's this reaction right here. So no reaction happened. Now I want to point out that there's another instance where we'll see no reaction happen, and that's going to be with the lead 2 nitrate when we add lead to it. So this is the same situation, right? We have the same metal switching places, so the reactants are going to be the same as the products. So we can write an NR here as well, because we won't see anything occur for that reaction. So now let's move on. We're going to stay in the copper column using the copper 2 nitrate, and now we're going to react it with zinc. So this is the space where we're going to be recording our next observations. So copper 2 nitrate with zinc. This guy here. All right. So our copper 2 nitrate solution is a clear blue solution. You can see in the test tube here. And we are adding those solid zinc shavings to it. So tossing those into the test tube with the copper 2 nitrate, and then you can see in the picture to the right, here are the results. Now notice the solution is still blue, so we don't really see a color change there, but look at what's happening to the metal. Does the metal look any different? Record your observations. Next, we're following copper 2 nitrate once again, this clear blue solution, and we're reacting it this time with solid lead. So you can see the solid lead pieces here. Now once we add the solid lead to the copper 2 solution, notice definite changes. There's bubbles, color change, has it all. So go ahead and record your observations in the appropriate spot in your lab manual. Next, we're going to be using lead 2 nitrate solution. So lead 2 nitrate solution is a clear colorless solution. We're going to start by adding solid copper pieces to it. So we add the solid copper pieces and we have the results over here. Now notice the solution is the same color. It's still clear and colorless. Also notice, look at the copper. Does the copper look any different? I don't see any color changes, kind of looks the same. So if nothing changed, no color changes, no bubbles, no solid forming, then you would write no reaction, or NR, in the appropriate space on your data sheet. Next we have lead 2 nitrate with zinc this time. So we have the solid zinc pieces added to the lead 2 nitrate. Now off to the right I have two pictures just so you can see it from two different angles. You'll notice in this first you can kind of see the bubbles forming on the solid. And then looking at the solid a little closer you can also see there's a color change. The reactant zinc was shiny silver, but now it's dark blackish. So record those in the appropriate space of your lab manual as well. So the last reaction we've already talked about, we should have already written NR there. This is where we had the lead 2 nitrate reacting with lead. So since it's the same metal, the reactants and products are the same. indicating that no reaction occurred. So here are some of the single replacement reaction questions that you'll need to answer for the lab. So I have here the observation data that you should have all filled out. Remember, we had a no reaction here and a no reaction here, so you didn't see these ones. For all the other ones, you'll write the observations or NR if there was no reactions in the pictures that you were previously shown. So with this new knowledge, we can go to answer questions in Part A. So Part A is referring to these reactions that we just saw. The first question wants you to write the balanced equations for the single replacement reactions. So this is in another video in the folder showing you how to come up with those single replacement reactions. So it's where, for instance, this first one here, we're taking silver 1 nitrate and reacting it with copper. So you would need to write that equation out. So you would have AgNO3, oops, hard to write on here with the mouse, plus copper, and then you would need to write the products, predict the products and write them out. So to answer that question, the other video will be more helpful in helping you predict the products and balance the equation. Now for number 2, it asks which solid metal has the greatest number of reactions. So for this one, what you're going to do is you're going to look at the columns going down. So you're going to look at copper, you're going to look at zinc, and you're going to look at lead. So based off of your data, which ones had the most reactions? So we know that copper has at least one NR, and that lead has at least one NR. So whichever one has the greatest number of reactions, you would put that one first, and then whichever one was next, and then third. So you're labeling them 1, 2, 3. So you're going to have zinc, lead, and copper all listed here, but you want to list them in the correct order based off of your observations. Now next, number 3, it says of the metals used in this experiment, which one is the most reactive and the least? Okay, this is going to be the same as number 2. Whichever one had the most reactions, it's going to be the most reactive. So you're still just using copper, zinc, and lead. Which one of those 3 metals is most reactive? So which one had the most reactions? Now for number 4, it's saying if we use a gold metal in addition to these 3, where do you think gold would be on the activity chart? So to answer this question, you would need to look up the metal reactivity chart and see where gold is. Is gold above copper, zinc, and lead, or below? Number 5, it's just asking you to summarize your observations. Did you see any color changes in any of the solutions? If you saw a color change, what does that indicate? So does it indicate a reaction occurring? Does it indicate no reaction? So just answer that accordingly. Now the last question wants you to write a general rule describing single replacement reactions, when they occur and when they do not occur. So to answer this question, you're going to use a metal reactivity chart. So you're using basically your answer for number 2. Which metal is the most reactive, which is the least? So when do the reactions occur? When you have a more active metal or when you have a less active metal? Let's move on to Part B. In Part B, we're looking at double replacement reactions. So here's the basic scheme for a double replacement reaction. You have 2 compounds reacting together, and they're switching places. So compound AB reacting with compound CD. And what we have is A partnering up with D on the product side to form AD. Then we have the other 2 ions, C and B, partnering up to form compound CB. So you'll notice another chart for listing your observations. There's a lot more reactions on this side. So we're going to start with silver nitrate and follow our way across. So our first reaction is going to be with silver nitrate and copper 2 nitrate. Now, for this reaction, you'll notice that we have something in common here. And what we have in common is the anion, the negative portion, NO3. So notice we have NO3 in both reactions. So this is very similar to those single replacement reactions when we had the same metal in both reactants. So if we have the same non-metal in both reactions, the same thing's going to apply and we're not going to see anything happen. It's going to be an NR, no reaction. So let's look at this a little bit closer. We have AgNO3 and PbNO3 reacting together. So what happens is we have, we'll call this A, and it's going to partner up on the product side with D, and D would be the NO3. So we have A and D together, and then the other product is going to be C and B. So C being the silver and B being the NO3. But notice we just said since the anion portion, NO3, is the same in both reactants, the reactants are exactly the same as the products. So when that happens, nothing actually changed, so there is no reaction. So let's look at this chart again and go ahead and label no reaction for all of the mixtures that have the same anion in them. So we have AgNO3 with copper 2 nitrate, so they both have nitrate in them, so we're going to write NR for no reaction. The next one, if we take silver nitrate reacting with lead 2 nitrate, notice we have nitrate in both, so reactants and products are going to be the same, so we'll have NR there as well. Now the next reaction, silver 1 nitrate with HCl, those are completely different. So we might see a reaction there, so we'll have to look at the actual experiment to see. So we only do write NR for ones that have the same anion. So copper nitrate with lead nitrate, this box here would be NR because they both have nitrate in them. Going through, we have HCl with BaCl2, they both have chlorine in them. So I would write NR. And that's all the ones that I see offhand. So now with the remaining reactions, we're going to be looking at some photos to determine if a reaction occurred or not. Now the thing with double replacement reactions is the driving force for them to occur is formation of a solid. So when we're watching these reactions, what we're going to be looking for is cloudiness. Doesn't matter if it's white cloudiness, yellow, red, if there's a cloudiness forming, that means a solid, a precipitate formed. So the first double replacement reaction we're going to look at is silver nitrate with HCl. Now the silver nitrate is actually a clear colorless solution. You can't see that because of the tinted bottle. And then HCl is also a clear colorless solution. So when we add both of those together in a test tube, this is what we'll see. So we do see a white cloudiness forming. So record that in your observations. So we're looking at the silver 1 nitrate with the HCl, so it's this box here that you will be recording observations in. Next, we're going to move on down the line, doing silver 1 nitrate again, and this time reacting it with potassium chromate. Silver 1 nitrate is a clear colorless solution. Potassium chromate is a clear yellow solution. Now look at what's happening when we add those. So we have the silver nitrate, the clear colorless solution, already in the test tube. And you can see by this yellow pipette, that's the potassium chromate that we're adding. And the second the two hit, we form this deep orange, rust-colored solid. So make sure you are recording that in your data sheet as well. Next, we're going to be looking at silver 1 nitrate reacting with barium chloride. Both are clear colorless solutions. When they are added together, this is the results. Next, we're going to be observing copper nitrate. Now, the first reaction, we have it reacting with lead 2 nitrate. But remember, we wrote an NR for that since there's nitrate in both of those. So what we're going to look at first is actually the copper 2 nitrate with HCl. Copper 2 nitrate is this pretty clear blue liquid. We're reacting it with a clear colorless HCl. Now when they're both added, we have a blue liquid. So, do you see any cloudiness there? There's no cloudiness, that means no reaction happened. I don't see a color change either because we started with a clear blue solution and we're ending with a clear blue solution. So record your observations in the data table here for that reaction. Next, we're taking copper 2 nitrate and reacting it with potassium chromate. So copper 2 nitrate, clear blue solution, potassium chromate, clear yellow. When both are added together, we do see a cloudiness form and once again a rust-colored solid forming. So record that in the appropriate space. Next we have copper nitrate and barium chloride. Clear blue reacting with a clear colorless. Once again, no cloudiness forming. So it still is a clear blue solution. So I don't see a reaction occurring here. So make sure you record that in the appropriate spot. Next, we're going to be looking at lead 2 nitrate reacting with HCl. Lead 2 nitrate is a clear colorless solution. We have HCl, also a clear colorless solution. When the two are added together, we do get a white cloudy precipitate forming. So make sure you're recording that in the appropriate spot in your lab manual. Now next, we're going to look at lead 2 nitrate with potassium chromate. Clear colorless, reacting with a clear yellow. And notice, so we have the lead 2 nitrate here, it's the clear colorless solution. You can see by the yellow pipette, that is the potassium chromate that we are adding to it. And when we add it to it, it's no longer a clear yellow, it's now a cloudy yellow. That's indicating that a solid is forming. Make sure you are recording that as well. So we're looking right here. Next, let's take lead 2 nitrate and react it with barium chloride. See what we get here. Clear colorless, lead 2 nitrate reacting with clear colorless barium chloride, and we do get a white cloudiness. So next we're going to look at HCl reacting with potassium chromate. We'll write our observations here. Clear colorless HCl reacting with clear yellow potassium chromate, and all we get is a clear yellow solution, so no solid forming. And remember, the driving force of double displacement reactions is the formation of a solid. So if no solid formed, that means no reaction occurred. Next, let's look at HCl, this time with barium chloride. Well, HCl, barium chloride, oh, they have the same anion portion. They both have chlorine in them. So since they both have chlorine in them, this is a no reaction. So we don't even need to look at the two being mixed together. So let's move down now and look at the last reaction, potassium chromate with barium chloride. So our last observation will go here. So we have a clear yellow solution, potassium chromate, reacting with a clear colorless barium chloride. So we have the barium chloride in the beaker and we are adding the potassium chromate to it. And as soon as it hits, we do see cloudiness, so a solid did form. Now let's look at how we're going to be using the data that we just collected. So these are the double replacement reaction questions. So for part B, the first question asks you to write balanced equations for the double replacement reactions and indicate with a down arrow if any precipitate, which formed. So let's look at the last example that we just saw. So we just saw potassium chromate reacting with barium chloride. So when this happens, a double displacement reaction occurs and we have barium switching places with potassium. So barium on the product side is going to be with the chromate ion and potassium is going to be with chlorine. Now we did see a solid form. In the previous slide we saw a pale yellow cloudiness form. So that means a solid did form. So the question wants you to indicate with a down arrow which of the products formed a solid. That's what precipitate means. It means a solid formed. So is it the potassium chloride that formed the solid? Or is it the barium chromate that formed the solid? So to figure that out, you're going to use your solubilities chart. So let's start with this product, potassium chloride. So to use the solubility chart, you're going to find potassium and you're going to find chlorine. So when potassium and chlorine come together, they form S. So what does S mean? Now this is a little confusing. S does not mean a solid formed. What S means is soluble, and soluble means dissolved. It means it's an aqueous solution. So S is soluble, meaning no solid formed. Okay, so KCl, potassium chloride, is not a solid. Let's look at the other product, barium chromate. So we find barium and chromate and see where they intersect. And they intersect, there's the letter I. What I means is insoluble. So insoluble means that yes, a solid formed. So that means barium chromate does form a solid. So how I would indicate that in number 1 of part B is by putting a down arrow next to it. So you want to do that for all reactions that formed a solid. So you would list them all here, making sure you have the correct products, that it's balanced, and then adding the down arrow next to the product that does form a solid. And that's indicated by the letter I on the solubility chart. All right, let's look at number 2. So number 2 is asking which negative ion has the greatest solubility in water. So it's asking for negative ions. So you're just going to focus on these 3 negative ions along the top. And it's saying which one has the greatest solubility. So you're looking at which one of those 3, chlorine, chromate, or nitrate, which one has the most S's, because S's means soluble. So whichever one of those 3's has the most S's, that's the greatest solubility in water. The one that has the most I's is going to be the least soluble in water. So you're using the solubility chart to answer that question. Number 3 is very similar, except for this time it's asking for which positive metal ion. So now you're going to look at all of these possible ions here with the positive charges and then follow them across. So which one of these positive cations has the most S's? The one that has the most S's will be the greatest solubility in water. The one that has the most I's, or the least S's, will be the least soluble. If you have more than one, label both, because you might have two cations, two metals, that have all S's. So you would list both of them as having the greatest solubility in water. That takes care of Lab 6.